What exactly is going on when a protein or other molecule binds with a receptor? So the sort of thing that instantly comes into my mind is like a key fitting into a lock, or like a puzzle piece connecting with a neighbor. But the scale is far too small for those sorts of concepts of rigidity or even solidity, right? The answer: receptors are proteins, which are made up of amino acids that fold into a particular three-dimensional shape. Different amino acids can also have different properties, such as positive and negative charges, hydrophobic or hydrophilic side chains, etc. Receptors can also be modified with sugars, lipids, etc. But the ligand binding site is usually just amino acids. When a ligand, protein, or other molecule binds to the receptor, it will interact with the amino acids in the binding site based on their 3D shape and physical properties. Charge, hydrogen bonding, etc. The binding affinity of the ligand will depend on how strongly it interacts with the binding site. This is how the receptors establish selectivity for binding some molecules instead of others. You can think of the binding event like a hand fitting into a glove. The glove will change shape a bit when the hand goes into it. This conformational change in the receptor can cause downstream biological effects, depending on the function of the receptor. Many receptors are kinases, which phosphorylate proteins when the ligand is bound. Also, some inhibitors, called competitive inhibitors, will bind to the receptor and not cause conformational changes like the normal ligand, but still occupy the binding site. Regarding the question of rigidity, solidity, proteins can be more or less flexible, depending on the protein, but the individual bonds are pretty rigid, and most receptors will have only a few stable conformations. Follow this channel for more Santa Explains. And if you have any questions I should answer, just write them down in the comments.